Um, I'm Trevor Stricker, and I'm here to talk about Quickhit Football. So before I start, a few quick questions, because I assume more than half the people here aren't American. Is anybody a football fan? Nice. Has anybody played Quickhit? Does anybody play Madden or NFL 2K? Um, so first thing I want to talk about is what is Quickhit? And you can actually check it out right now at quickhit.com. I don't know if it'll work on the Unity Wi-Fi network, but we could see. So Quickhit is a browser-based, free-to-play game. So if it's free-to-play, how do we make money? We monetize by ads and through microtransactions. It's a coaching strategy game. So what that means is you make coaching decisions. You call plays, you train your players, you decide when to call a timeout. The goal is a high-quality game, a premium product, but we also want to stay highly accessible. There are a lot of casual football fans out there who don't have a console or can't be bothered with NFL 2K or Madden. We serve about 40,000 games every day. That's games, and some of those games are single player, some are multiplayer, so it's more people than that actually playing. The interesting thing about us is we're in both Unity and Flash. A lot of that's because we came out with our Flash version first. A lot of that's because in the Unity game itself, we actually use Flash for things like the menu screens, the loading screens, and to show ads. And I'll get onto that. Also, we are a licensed NFL game. We're an official NFL product. Now, why is this significant? About 6 years ago, Electronic Arts signed an exclusive license with the NFL and with the NFL Players Association and with ESPN. They ended up spending more than $1 billion to lock down the license. This is obviously a huge category of games in America, and so we're the first licensed product in video games, the first video game to have the NFL shield on it for quite a while, besides Madden. Today I'm going to talk about game development issues centering on Unity. I'm going to talk about our approach to developing Quickhit Football. I'm not going to focus on other issues like design, like how we buy traffic and distribute the game. I can't share our business details, and I can't really talk much about our approvals process with the NFL. But trust me, if you're doing a licensed sports game, getting your assets approved by whoever the league is, it's a lot of work. Also, we used Unity 2.6. Now that the football season has started, we've been too busy maintaining the live site to upgrade to 3 yet. Some of our problems may be fixed in Unity 3. We certainly hope they are. So some brief information about myself. I'm the director of games at Quickhit. I've made console games for about 12 years, pretty much every console since the Dreamcast. Some of the games I've made that have either been the best reviewed or sold the most, not always the same thing, are NBA 2K, Panzer Dragoon Orta, and Fantastic Four. So a few years ago, it was apparent to me and a lot of other people that the box retail model of video games, it's sort of entering the twilight. Sure, there are massive hits like Halo or Call of Duty, but at the same time, digital distribution is on the rise. Everybody knows about Steam. All the consoles now have their own digital distribution channel, like Xbox Live Arcade. Even BitTorrent is digital distribution. Also, there are companies coming up making free-to-play social games and making a lot of money. Zynga last year, or rather Tencent last year, had more than $1.8 billion in revenue, and that's mostly from Chinese consumers. On this continent, Zynga is fast approaching that, and like many people, I jumped on the bandwagon. So now, first thing I want to go over is some of the things that helped us develop the game. A brief overview. We use C#. Why did we use C#? Seems to work fine. I don't know why we weren't really concerned about it, having a English readable scripting language like JavaScript. Our artists use 3D Studio Max. We use Perforce for both our assets and for source control. Our server code itself is written in Java, and it's something that we wrote in-house. Our web, it's not actually a LAMP server. It uses Linux, Apache, MySQL, and something called Grails, which has worked pretty well for us. The thing, of course, I have to mention here is that Unity's integration with Perforce isn't that great. Unity will just write to a read-only file instead of warning you or checking it out. Meta files don't like to be branched, specifically for models. We've noticed that when we do that, it crashes on import. And Unity does not handle multiple people working on a project very well at all. Having those scene files can't be merged, and those can cause real contention during development. Some brief stats on the development team. The Unity project itself had 4 full-time developers, 1 veteran programmer who was kind of a Swedish graphics ninja, 1 veteran artist, 2 junior programmers. There were 6 developers that were shared with the rest of the team, doing things like AI, Flash, the game designers, obviously. The game itself, like I mentioned, is a Unity Flash hybrid. I'll show you in a bit. We use Flash for things like the loading screens and obviously for the website. We did do a little bit of outsourcing for things like the uniforms. And the total project time was 9 months from the time we started development till we actually went live in September. So the first obvious question is, why Unity and Flash? So like I mentioned, our goal is a massive, successful game that people love to play, and that's mainstream. So our question was, we made the Flash client first, and our question was, will a high-end client perform better? Or will a mainstream audience even care? What does it mean to perform better? Does it mean more people are spending on microtransactions? Does it mean people play the game longer before they surf away to something else? Does it mean just more games played in general? So obviously for Unity, Unity can be gorgeous. Will it look as good as Call of Duty on a tricked-out PC? Not if you look at them side by side. But I've got a cousin who loves football and doesn't consider himself a gamer. His computer is a Dell from a few years ago. It's got onboard graphics. He's about 30 years old. So what he does have, however, is disposable income. And for a guy like him, it looks good enough. And he can play from work. So what we hope is that higher production values mean more perceived value to the player and an increased willingness to spend money. Or that's the hope. So what are the benefits of Flash? Why do we still have this Flash game? Why did we use it? Well, in one word, it's ubiquitous. Everybody has it. Every single person who surfs by our site can play our Flash game. But if our goal is to be a high-end game, why are we limiting ourselves to what's essentially the lowest common denominator? The thing is, every hoop you make people jump through when they come to your game leads to abandonment. Even just getting their email address. Requiring a plugin turns away actually the majority of casual web surfers who just swing by, even with the streamlined install that Unity has. We've noticed that about 15% of our new visitors have Unity already, but really at the end of the day, it's a numbers game. We want as many of our visitors as possible to be dazzled by the wonderful game that we've made for them and to become regular players. And Flash gets them in as quickly as possible. So on the web, we can measure everything. So what's the real-world impact of Unity been? So it's only been live for a little less than 3 months. That's the football season so far. Users without Unity, when they come to the site, are shown a dialog box prompting them to install Unity with a a screenshot of the 3D game so they can see how much nicer it is. About half the people who come actually do the install. And we've noticed that Unity users play about 25% more games on the first day. So while that doesn't sound like an earth-shattering difference, over time it actually compounds. And a lot more of those users, we hope, will become the long-term users that we really value. But like any business, we're actively trying to figure out what the impact is on our bottom line. So now I want to go over the architecture of the game. Because it's a coaching simulation, it's a synchronous network game. As a player, I submit my play, and everything that happens in the game is simulated on a server. The server is trusted. All you could really do if you were to hack your game is maybe get more time to call a play, and that doesn't really bring you that much value. So there's one protocol that talks to both our Unity client and our Flash client. Now, of course, this sounds obvious. I mean, why wouldn't you do it this way? But in real life, it's very difficult because both clients have radically different capabilities. So it's much easier said than done. The real-time elements that are involved have to do with the play clock. In other words, if you don't call a play in enough time, just like in a real football game, you get charged for a delay of game. And that's the only thing you could really hack on the client. So both clients send their commands to the server, which is, I want to call a timeout, or this is the play that I want to call. I want to throw the ball. I want to run the ball. The server runs a simulation and returns the results to the client. And the R with the bar above it, it's R bar. It's the result set. That's just a network game term for this is what happened. The result set, the results of the simulation, contain the animation time for each player in every frame of that simulation. And it also contains events. So those events are for things like, when do you play a tackle sound? When does the whistle blow? When do you flash up a notification, touchdown? Each one of those result sets, I can actually show you one. Oops. So you can see it right here. It's XML. There's nothing really that proprietary here. You can see their position, the player ID. At the very end, you can see which animation they're playing. An example of some of the results, you can see the line scuffle, which is when the guys on the line hit each other, makes a noise. Those results can actually get pretty big. They can be about 1.5 megabytes, but as you saw in the XML, it's very repetitive. It compresses down to about 200K. That raises another question, which is, if it's the same animation ID and animation time for, sorry about this. If it's the same animation time and animation ID for Flash and for Unity, how do we display these beautiful, gorgeous 3D animations in that top-down Flash view? And I'll get to that in a moment. So, obviously a big concern in a network game is loading. Quite simply, the longer your game takes to load, the more people will abandon their game before they've even gone into it the first time. For longer-term players, that's actually less of an issue because they're already hooked. We've actually heard from users that sometimes, whether they've got a slow computer or a slow connection, that it's taken them up to 20 minutes to get into a game, and they weren't even complaining. Obviously, you've got to provide feedback. You've got to show the progress. That sounds so obvious, but there are so many network games out there that just don't do it, or where it hangs on 30%, or even hangs on 100% for up to a minute. Now, you clearly want to load your critical assets, and only your critical assets, before you enter the game. The problem is, in a sports game, we're drawing basically 22 interesting objects in a bowl. All your big critical assets, you need them before you ever get into the game. But we do actually have some assets we can load after we get into the game. There's a player information panel in the bottom corner of the screen that it shows the stats for that player, and it shows a headshot. When you consider that between two teams you have about 100 players, well, that's a lot of assets that we can load after the game starts. Also, when you call a play, and you'll see this in a moment, it shows the graphics of what the play does on the field. There can be up to 400 plays in the game, and those images are pretty big, and that's significant memory savings. The load time scales with your connection speed, that's obvious, also with the speed of your computer. Part of what it does when it's telling the user it's loading is it's actually unpacking assets and doing some of our local client-side baking. What we notice is that on a fast machine with a good connection, you're only loading for about 40 seconds. Would we like to improve that? We would, but we think that's pretty good. Like I mentioned before, our game is actually a hybrid of Unity and Flash. So this loading screen, it's a Flash widget, and then you get into the game, and you're in Unity. But if you notice, above Unity is a Flash ad. So because we got to pay the bills, Flash is always visible throughout the whole game. We would love to be able to render Flash from within Unity using something like Scaleform. Unfortunately, we can't. That prevents us from doing a lot of things we'd like to do, like going full screen. It also prevents us, because we can't render Flash over Unity, it prevents that ad on top from actually expanding and going down. Why would we want to do that? Those ads are more valuable, and advertisers are our friends. Like I mentioned before, our loading page is a Flash widget. Unity is actually controlling swapping between Flash and Unity itself. And Unity is doing all the logic. So the loading percentage you see right here actually comes from Unity itself. When we're displaying one of them, the other one is a widget that's a single pixel. The code to glue them together is based on the U3D object by Akiris. And I know they're here, and that was an awesome thing that they made. We did have to expand it a little bit because we're actually sending a whole ton of data back and forth, up to a megabyte. And the U3D object as it existed, it tended to choke on that. But it was a great thing. The next thing that was really important to us is the build. So one problem we had is that in a production environment, you always need the latest version ready to go. And you could potentially have multiple branches. You could have some people developing in a version that's almost ready for a deploy, and you could have the rest of the team working in the trunk. Sometimes you even have a sub-team working in a feature branch doing something that's not even designed to go live for a month. So the way our game works is we have a build server, and the build server builds things like our Java game server, our Grails website, the Flash client, and it's a continuous build process. So every time somebody checks something into Perforce, it kicks off a build. That's really useful because QA can get the latest whenever they want. When you're getting ready to go live, you can push directly from the build server to our staging server. Every single component of this system needs to be able to be built with the push of a single button. It would be absolute madness if you had to build these things separately because we're only adding components. And fortunately, all of our systems work with the single press of a button, except for one. Unity requires a Mac or a PC with a physical graphics card, even for the command line build. So we can't put it in a VM, and this was a huge problem for us. So how did we fix it? Well, we got a physical build PC for Unity. This is an actual physical machine that's devoted to Unity builds. The build server, every time we do one of these continuous builds, the build server sends a request to the Unity build PC to build a branch that we care about. It copies that branch into a working directory, the working directory has an existing project set up. Unity is executed in command line mode. It exports all our asset bundles, it builds all our binary assets, and then those are copied to the target server. It's not as good as we like. It took us a while to get it stable. And when we do multiple simultaneous builds, it can be very slow. Next thing I wanted to talk about is the animation pipeline. So like I was mentioning before, we have these beautiful, gorgeous 3D animations that Unity displays just fine. And what we need to end up with is a tile sheet for the sprite animations that Flash can use, like you see on the end. Also, it's not just visual. We need the physical properties of these animations themselves. Why do we need physical properties? We need to know where the hands are, where the football is in the animation. If a running back gets tackled and the ball were to shoot out of his navel, it would look pretty ghetto. So on the server itself, we have to know where the ball is in his hand so it can fall out naturally. So the first step, we've got the animation itself that was built in Max. We only have on the order of 100 animations, so it's not a huge data set. Each animation is extremely expensive for our 2D client. Unity supports Max natively, so that's easy. We just import it into Unity and it makes an asset bundle and everybody's happy. Now to get that data to the server that I mentioned, we actually have a data build running on our build server that crunches through all the animations and pulls out things like the translation and where the hands are. How do we get this to the server? We actually export it, we actually create Java code for it. This may seem a little tortuous, but we're trying to optimize for runtime speed. Because we don't have a huge amount of animations, but we have to access that animation data multiple times every frame, the quickest way you can do it is by static data that gets loaded into Java. And as for the Flash animations, in Max, we have a whole massive set of scripts that go through the animations and take and render it from a camera above at 15 frames per second, then composite all those animations into a tile sheet like that. Now, because that's a sprite, we can't just apply a new texture to his uniform like we can in 3D. So for every team and for every uniform, we actually have to render a separate tile sheet. We're doing it at 15 frames per second. For Flash, that's very optimistic. We can probably drop it down to 10 frames a second and you wouldn't even notice a visual difference. How many tile sheets are there? Well, we have about 100 animations, 32 teams, 2 uniforms, home and away for each one. It's about 6,400 tile sheets. We can generate one team's worth of animations in a few hours. To do the whole build, it takes about a week. Another thing which was really hard for us to figure out is how do you draw the numbers on the back of a uniform? So every player's got a unique number, obviously. In 3D, it's fairly simple because you've got a texture back there, and we can have the shader actually looking up in a texture full of numbers to draw the left number, then to draw the right number. But you can't do that in 2D. You kind of have two options. You can bake a tile sheet for every single possible number and have 100 times the amount of animation data, or you can have a tile sheet with the numberless football player and then have a tile sheet for the left number and the right number, and then you have to draw each player 3 times. Well, we came up with a compromise. You'll notice this guy right here is number 0, 0. All the players in the Flash game are 0, 0, and I've yet to hear anybody complain. Debugging. I wanted to talk a bit about how we debug the game both during development and now that it's live. So first of all, in-game, we have this is what we actually see as developers. This is the debug display. And if you notice right here, here's the player info panel. There is no portrait of the player's face right there. The game must have just loaded. So the first thing we have in the top right is what state the game is in. This helps us debug race conditions. You know, when you have two clients connected to a server and a very complicated state flow, what do you do if each client requests a different state change? Well, that's going to happen in the real world, and you've got to handle it, and displaying what state you're actually in is the first step for that. There's also the build info. Now, this sounds obvious. Of course you'd want to, why do we care about this? Towards the end of a release, you don't have obvious differences from build to build. Sometimes it's not even in the graphics. It's just kind of under the hood. Having this, the worst thing that can happen is when you have a hard to reproduce bug, QA spends a while, reproduces it, and then you discover that it's because they've got a stale version in their browser cache. So that helps us avoid that. We can also save the results of a simulation. That's important because a lot of AI bugs are really hard to track down or very rare. So being able to save the results of a simulation helps us debug it after the fact. And we can display the amount of memory we're using. A big problem we had in Unity is debugging memory leaks. C# makes it, because it's a managed memory language, it makes it impossible to figure out where your actual memory is coming from. You can't put a breakpoint in the allocator. You can't put any sort of debugging in there. And we've noticed that allocations happen sometimes in the most random of places. All we can really do is take something out that we think might be allocating memory and run it again and see if the memory usage is higher. If anybody's got a better solution, I'd love to know it. Some other things here in the top right, it's kind of hard to see. It also displays the frames per second. So the other big thing we have to debug is communication itself. You know, we've got a lot of components in the whole system. We've got a web page. Clearly, we're a web game. And that will do things like talk to the game server to set up a game, request assets from the CDN. The CDN is, for those of you who don't know, that's a content delivery network. Essentially, we have a lot of assets that are the same for everybody, whether it's pictures of football players or the game client itself. We could serve those from our data center, but Akamai can do it much quicker and cheaper than we can. So we've got the web page. The web page also talks to the data service to get information about the team or about my player account. Then once we start a game, the game client starts up within that web page. The game client obviously has to talk to the game server to run simulations. It's got to pull team data down from the data service. It's got to pull those player portraits down from the CDN. There's a lot of components talking to each other here. And there's complicated state transitions. So how do we figure out what's going on? The logger. This is actually an application that runs on both Windows and Mac. It displays all network traffic to and from the server. It displays what the client is thinking, why it makes certain state transitions. Like I was saying before, a multiplayer game, it's fertile ground for race conditions. What if one player wants to call a timeout while the other player wants to hike the ball? What if both players call a timeout at the same time? Who gets charged for it? We've had so many issues like this, and knowing exactly what each client is doing helps us a lot. These can be saved as text files, so you can email them to debug later. And everybody must use it. Everybody. Not just QA, even our CEO. Even our marketing guy when he's playing with his son. If you don't have a log, you can't complain about a bug. Because real-world situations just don't happen in QA. QA is, some guy monkey clicking through their 20th game of the day. They're not going to attack the buttons with the veracity of somebody sucked into the last minutes of a close game. A lot of our race conditions, timeout fails towards the end of a game, or the game just hanging, happen in these close call situations. Now I'd like to talk a bit about the workflow, how we enable our designers and our artists and the non-programmers to author content for the game. You need to allow your designers and your authors to author your game. They have to be able to rapidly iterate so they can make changes as quickly as possible, but they shouldn't be able to break the game or make it fragile. Also, obviously, artists need to be able to view their work in the actual environment. All this seems like conventional wisdom in 2010, especially among people who've made games before. But one thing about being a free-to-play game startup is you have a lot of people who've only made websites. And they don't necessarily know these things instinctively. They haven't been burned by them in the past. The cool thing is the Unity editor makes this possible. You know, we're not the kind of game that needs enemy spawn points or pathing, but we definitely do need to see our assets in the actual game environment itself. So the first thing that's cool is our camera editor. Cameras are pretty critical for games, especially for a sports game, where you've got to kind of balance displaying all the action as it happens with something that's dynamic and looks appealing. So what we can actually do is we can load up one of those simulation results and loop it, just play it over and over again. And we can even change the playback rate so that animators can see the minutiae of their animations. As this thing is looping, in real time, a designer can actually tweak camera values. And there's a lot of variables there. It's not just whether you're looking at the ball from behind the line of scrimmage or next to the sideline. It's also how quickly does it interpolate after the hike? How much does it zoom out for a long pass? How closely does it zoom in for running through the line? The problem we've had up till now is that as soon as you stop the game, these values go away. But Adam at Candlelight yesterday told me we can use the player prefs to actually serialize those as the game runs. So we'll be making a change next week. The statistics tester. The internals of a simulation have a huge amount of variables that we need to tweak. How quickly does a low-level quarterback throw the ball? How quickly does a high-level quarterback throw the ball? What percentage of the time does the running back break a tackle? What if the guy trying to tackle him is high level? How does that change the percentage? Every change is a risk. Whenever you change something on one end of the simulation, it's very chaotic. You risk breaking it in the other end of the simulation. So what the stat tester does is it runs millions of simulations, generates statistics on what happens to let the designers know what's happening in the game. And as you can see, it can scale to any number of servers, so we can really get any amount of performance that we want. We've got 294 offensive plays, 228 defensive plays. That's 67,000 play combinations. That's a lot of branching when you want each one of those to have some kind of feasible result. Typically, we'll just run it on a subset of plays. For example, we'll want to see how our zone coverage has affected the deep passes. But before we do a release, we absolutely have to do a full run on every possible play combination, and that can actually take up to 4 days. This also helps us find bugs within the simulation. Like I said, a lot of AI bugs are really hard to track down. Obviously, we're not looking at every single output of the simulation, but if it crashes, it makes it easy for us to make sure that our fixes have worked. Real-time asset tweaking. So artists need to be able to see their changes as it'll actually look to one of our players. Now, I'm sure people who make PC games or web games are like, no, duh, why don't you just see it on the screen? Well, for people who've made console games, this is actually a really hard problem. You figure your artist, he's working in Maya, he's working in Max, he saves his asset, quits out of Max, runs the build process, gets the binary asset, copies it over the network to the viewer, walks over to the viewer, turns it on, and then sees Xbox while it loads your game. Then he goes to the part of the level where he wants to see his asset, tweaks the lighting, loads up his asset from a menu, and then he can see it. Being able to do this is phenomenal. The artist can adjust colors, lighting, shader values, and they see it as it will actually look. The UI can be tweaked and adjusted. The editor also helps us resize the window to see how our UI is affected when somebody resizes their browser window. The director system. This is something which is really useful for a sports game. What it actually does is it analyzes the context of the game, and it triggers things to happen. What kind of things? Well, like it says here, voiceover commentary, change the camera, visual notification, so when you score a touchdown, it goes touchdown. Play-by-play in the lower right-hand corner, there's actually a text play-by-play, so you know exactly how far a pass went or who made the tackle. What it does is it has access to the whole state of the game, the score, the line of scrimmage, and it can do logic. So you can see from this example right here, when we want the announcer to say, and the offense recovers, close call, we want to play that when there is a fumble recovery, but not a turnover. And this system is actually, it's been phenomenally useful. It's all done in Excel, and then part of our data build, it actually sucks it out and makes something that our server can use. And we have multiple spreadsheets like this. And as you can see right here, here's an example when there's a loss on a defensive kick return. You can kind of see it's going to play this line when right here, when they get between -100 and -1 yards on a return. And this is a very sparse table. Like there's a lot of values here which aren't even specified for the vast majority of things. Ooh, here's my buddy. Problems. What is a postmortem without mentioning the problems that you had during development? Raise your hand if you love the Unity GUI. Oh. So before I go into these are just the major problems we had, the things that we didn't come up with an elegant solution to, the major ones that either cost us development time or really limited what we could do in our game. So everybody's favorite GUI would work. It works great for debug stuff, but it's not really something you want to use for your actual production game UI. Again, we would love to be able to use Flash and integrate Scaleform into Unity. Not sure if that's possible. Multiple developers working on a scene. You can't merge scenes, but you really need to have multiple people working on them. At first, we had this idea that every programmer would have their own personal scene that they would commit changes to and then just branch the code to the main scene, and the world would be a wonderful place. Did this work? No. What ended up happening is we managed it by hollering at each other. Memory profiling, like I mentioned before, finding memory leaks, it's so time consuming. It doesn't need to be that difficult. Maybe source debugging in Unity 3 will help. We're looking forward to trying it out. Rendering Flash over Unity, even not full-scale integration, but just being able to render that Flash widget over. Advertisers are our friends, and we want to make them happy. Stability when importing models, this was a consistent problem for us. We try and import, somebody wouldn't have started the game in a while. They'd import the latest into their editor. Wouldn't always work. And that's it. That's my postmortem. Does anybody have any questions? Do we have the microphone? Sorry, Chris, you want to yell? Oh, here's the mic.
Can you go back to your last slide?
Yeah.
Doesn't really matter, but on the question of stability when importing models, we're running into the same issues. Did you guys find any commonality in when it would happen and when it wouldn't?
No. What we think this was a result of branching our metafiles, specifically for Max models, but we don't know. We never got to the bottom of it.
I got one other question. But so post-launch, what has been your biggest challenges so far?
So when you're a live game, you're never really post-launch. There is no gold master on the web. Our biggest challenge is driving users to the site and figuring out the most effective way to monetize them. Because look, we want to be an awesome game, but there's a balance between being a really great game and being crassly commercial. And finding that balance has been the hardest thing.
I'm referring to a slide early on where you say glue code based on U3D object from Acurus.
Yes.
Can you talk about what that is and how you finally solved the Flash versus Unity problem?
Sure. U3D object. It's basically a JavaScript module which lets you shrink your Flash or your Unity widget down to 1 pixel, so you can only display. So basically, you can toggle between Flash and Unity. It also has a way to shuttle data between them. So, for example, some of our Flash screens are actually display your statistics at halftime, so you know which player has caught the ball, who's scored touchdowns, and that's all generated in Unity and sent over to that Flash widget. I'm pretty sure if you search for U3D object, U3D OBJECT, it'll come up. They've shared the source code in Google Code. That's just 2 separate widgets. So they're just 2 different div tags. We've got a Flash div tag on top and a Unity div tag below it. When they're displaying next to each other, that's easy. And we actually do a little bit of trickery there because you don't want to show the same ad throughout the whole game, because then somebody would play your game for a half hour and get 1 ad impression. And how much fun is that? So the Unity game actually tells the web page when to refresh the ad. But that didn't need U3D object.
Did you use anything of the? Oh, sorry.
Oh, right.
Yeah. Did you use anything of the network solution of Unity itself, or was it all your own code that you made with Java Server, like the socket server part?
No, we're just opening socket connections. We did have a problem with the version of Mono that shipped in Unity 2.6, where on Macintoshes it wouldn't always do DNS resolution properly.
Mm-hmm.
So this caused us no end of problems because, we're a pretty big game.
Mm-hmm.
We have about 25 game servers that are live, and we actually have to tell the client the IP address, not just the domain name. And when you're in a data center environment, you don't really know your external IP address. So we actually have our IT guy typing 25 different external IP addresses by hand into a table. So one reason we're excited for Unity 3 is they fixed that bug.
Thanks.
All right. Just a question on design decisions to begin with. When you started to do this, Flash was obviously on the table to begin with. It was?
We actually came out with the Flash game first. More to do with the makeup of the company and just time to market than anything else.
And so then at some point you decided you wanted to have a premium version of it.
Yes.
What design changes were then, or did you then have to obviously design the design would have been different for the Unity version than it would have been for the Flash? At what point did you, it's also a production question, like what point did you decide, okay, well this many people in the company are going to start doing Unity, this many people are going to stay on Flash or continue on Flash?
Sure. I mean, I guess the decision that we made to go with Unity wasn't so much a design decision as much as just a business decision. We're worried that a lot of people are going and saying, hey, look at this fruity little Flash game and it's free and whatever. I'm going to surf away after 5 minutes. So we really wanted to, when you sign the NFL, that's a pretty high bar to live up to. So we wanted something that would wow people. I mean, we're really ambitious with this game. In terms of the game design itself, it's the same game. We want to be very careful to kind of be feature equivalent between the two of them. The Unity one is just prettier. There are a lot of features that Unity has that Flash doesn't, like the whole camera system. We don't quite use all the commentary or all the razzle dazzle in Flash, but functionality they're equivalent.
Just one more question. Regarding, you obviously have your own data centers and you host itself. Did sort of the cloud-based system ever come into discussion at all into the future, like Azure or something
We've
like that?
considered it. It certainly would be nice if we could infinitely scale and just pay Amazon some more money and double our traffic. We didn't really want to tackle that from the get-go. You know, when you're building a game and you've got a hard deadline, which is when the football season starts, you try and only tackle the problems that you absolutely need to. So we're pretty scalable. We run completely on virtual servers. So we can kind of, with VMware, we can kind of juggle our server allocations as we need. Right now, we're running at just a fraction of our total server capacity. Should our traffic go up by an order of magnitude overnight, we could radically increase our server capacity in however long it takes Dell to ship us servers. Lewis?
Hi. As a live web game, you will probably update your game several times over the course of the year.
Sure.
So how do you handle clients having old versions of the game inside the browser cache?
We cache bust. So the way you cache bust is the URL is slightly different for each version, so it doesn't get cached.
All right, thank you.
Basically, the same question as before. How do you clear Unity's cache, actually? Not the whole cache, but if you update a version, how do you clear Unity cache?
We're not using the caching feature of Unity right now. We might in the future. The two reasons which would cause us to use Unity caching are to decrease load times and to decrease our bandwidth usage. Like I was saying, our CDN bandwidth right now is actually pretty cheap. And in terms of the load times, it would only be the first time you load into the game. That's the most critical load time. Once somebody comes back for their second or third game, we've already got them.
Hey, over here.
Yeah.
Can you talk a little bit about numbers for people who may have come in and started playing on the Flash, but then decide later to switch over to Unity? Do you have any numbers about that?
Nothing I can really share, except for the fact that we're not doing it very well. This is actually something funny you mentioned that. We were just talking about last week, that in order to increase retention, we actually want to start messaging people more regularly to upgrade to Unity. Anybody else? No, just implementation. So the question was to elaborate on why we're not using Unity caching. It's more, we plan on doing it in the future. We kind of consider it a tech debt issue that's not stopping us from monetizing the game right now. The reason it's not a high priority is because it won't fix that critical first game load problem. And we don't have problems with our bandwidth cost right now. But we definitely plan on doing it in the future. Yes?
Well, so can you hear me okay? So we have like an R team, and one of our big discussions is whether we should have them actually use Unity's editor and not just give us all the assets and then we put it in. A big portion is they're not very well organized, and they tend to not do things right and screw up everything. So what were some of your issues with that?
I think if you want to enable your artists to tweak color values and to modify the curve on shoulders, if your game has characters with shoulders in it, then you need to get them in the Unity editor. Saying that the reason they're not doing it is because you're not organized. I mean, you're not going to ship a game if you're not organized.
It's not so much that they're not organized, it's more that they don't know like how a programmer might organize their assets in the,
Sure.
They might not organize it in the same way. So we have that kind of struggle.
Sure. I mean, I think artists everywhere struggle with interfacing with programmers, whether it's being consistent on their naming convention, putting things in the right folder, actually using version control as opposed to having 20 different separate files with different versions. I mean, I think that's just the kind of thing we've got to educate artists, get them into a workflow, and show them that it's better for them.
And then following up on combining Flash and Unity.
Mhm.
Earlier when you were showing the screens, your GUI was kind of completely across the bottom? Was
Yes.
that part Flash, and then your widgets that overlaid were in Unity?
So if I can go to a game screen, like this right here.
Yeah, you kind of have the score and the timeouts and that stuff, the full bar on the bottom. So is that a Flash piece?
No.
And then the little overlay?
Actually, this might be a little better. So this is all Unity.
Okay.
It was a lot of pain to. This is a heinously complicated UI because if you look, what's kind of hard to see right here is in this right here there are actually separate buttons. This is an old version, so that you can actually. There's a button here where you can flip the play to reverse it. There's a button here where you can press a heart to like it, so it basically bookmark it. So when you have buttons within buttons in Unity, it's just sheer madness.
Is there a reason you guys didn't go? I mean, it might not end up looking as nice, but it might have made things easier along the way to communicate between Flash and Unity to drive your action.
Yeah, I mean, our goal was to make it look nice.
Hello. So I was wondering, as you have some very heavy calculation in your game, have you ever considered using some GPU solution on the server side, like for sprite calculation or your big simulation?
Sure. We definitely have. I guess the reason we haven't gone with a GPU-based solution is because it's, the nice thing about servers is we can have these huge honking Dell servers with double-digit processors or double-digit cores, 32 gigs of memory, and we do have a multi-threaded server, and the server just crushes it. It just eats it. I'd say before we did that, we would probably get rid of the VMware abstraction and just go straight to the metal. But the nice thing about VMware is it makes scaling really easy.
Hi. Did you use the same poly counts for renders to sprite sheets that you did for models in the game?
Yes. So rendering to a sprite is actually a difficult thing, especially because those sprites are low res. It's kind of a similar problem to when you're generating a screen font from a true type font. Oftentimes, subtle, whether a pixel is, oftentimes single pixel differences make something look good or look like crap. So what we ended up doing, we used the high res models, the highest LOD models, and we render to a texture that's much bigger than the sprite's going to end up with. And we use Photoshop or Image Magic to scale it down. Do you remember which one? We have a script that uses, I can't remember, we've tried them both, Photoshop or Image Magic, to go through and scale those individual renders down. And that's what we found gives us the best quality. And that's one reason why it takes a week to render everything, because it's slow.
And did you quantize the output with PNG quant or something to get smaller sprite sheets?
No. We just used whatever the PNG export from Image Magic or Photoshop is. Anyone else?
Hi. Can you talk a little bit more about sort of compression of the data going between server and client?
Do you mean for the simulation result or for
Yeah.
the assets? The simulation result.
Simulation results.
It's easy. We zip it.
That's it.
You
How
can
do you unzip it on Flash end?
There's a library we found.
Okay. Nothing special.
If you look at XML, I mean, 90% of this data is replicated. That's not what I wanted to do. There's so much duplication in this data. So, I mean, if, every frame is going to have one of those player IDs. Almost every entry has this player. One thing that zip compression uses is dictionary compression. And so all those really long strings basically just become a stream of bytes that's replicated. So it compresses really well. It compresses almost to 10% of its original size. Assets, we use Unity's, whatever Unity does for its asset bundles. I think it uses LZ. I think it uses Huffman. It works great. The game itself, we've got about 100 megabytes of uncompressed assets, and Unity compresses them to 15, 16, 17 megs. So, at that point, it wasn't really worth us spending time on. Anything else? Well, cool. I hope you guys come online and play some Quickhit.